This week we'll talk about semantic modeling. Specifically, we'll talk about some of the basic ideas behind semantic modeling, as well as some of the basic symbology used in entity relationship diagrams. Let's begin. The word semantic you can equate with the word meaning. And really when we talk about semantic modeling, we're talking about database designers trying to model or create a formal model of their data set before actually implementing it in a commercial database. This often involves a lot of back and forth between a designer and the clients, between the designer and the tech people. A lot of different conversations need to go on so that everyone's on the same page. Meaning, in terms of semantics, as we describe it here, is all about the data. What are the tables? What are the fields? What are the integrity constraints? Ultimately, it's the hardware and the software which have limited semantic knowledge. In other words, they don't think about the data that it stores. They just store it in the way that we tell them to. Therefore, it's up to the application developer to present the data in a nice, visually pleasing way, as well as the user to use it in a way that's meaningful to them. It's the job of the database designer to represent that meaning for that data so that the application developer and the users can do their job. This process aids in system design and ultimately in documenting the contents of the database. Our ultimate goal is to understand the semantics of the data. What is the meaning of the data that we wish to store, and how does it fit in the larger picture? The first thing we need to do is to identify the entities and relationships of the data set. Once we have that, we can construct a formal model. Integrity constraints are also part of this, not so much in the visual end, but more in the documentation end. Our result is a data model, a formal system with structural, integrity, and manipulative aspects, which you recall are the three aspects of the relational model. We'd also talked about different phases of database development, one of which was conceptual data modeling. This is one part of the semantic modeling process. This is where we actually produce what we call a set of schemas or data descriptions through entity relationship diagrams. This has been with us for quite a long time, and the main idea here is that we're creating a pictorial model of the entities, attributes, and relationships in a fairly generic way so that that model can be used and translated into a DBMS, specifically any DBMS that we might want to use. Entity relationship diagrams are meant to be abstract and not meant to be vendor specific. Obviously, the term ER modeling constitutes two main pieces, entities and relationships. But how do we figure out what they are? When you're given a problem, often it's in written form or sometimes in verbal, it's up to the designer to identify the entities that make up the data that we need to store. Generally speaking, we think of an entity as something that can be distinctly identified. If you were reading a problem description, you might look for the nouns, for example. Some other terms you're going to see pop up during this process are weak entities and regular or strong entities. Weak entities are those entities whose existence is entirely dependent on that of another entity. They often don't exist without the other entity. A regular or strong entity are those that stand on their own merits. As you go forward and do some ER modeling, and through some of the examples we'll see here, that will become more apparent, the distinction between these two concepts. So let's look at some basic symbols of an ER diagram. Entities are represented as rectangles, often broken into multiple horizontal lines. In this case, we have one horizontal line across the patron entity. Above the line is the name of the entity, in this case patron, and beneath that are the attributes. The primary key attribute is usually underlined. On the pet entity, you see less attributes, but you also see an attribute that has its name in italics. When you see an attribute in italics, this is a foreign key. Relationships are indicated by lines connecting entities. In this case, it's a dotted line with symbols on either end of the line. We'll get to what those symbols mean in a moment. But in general, this little diagram you see here is meant to convey a particular type of relationship between patrons and pets. A patron has one or many pets, and a pet is owned by one and only one patron. So let's take a deeper look at these relationship symbols. When we look at the relationship lines and the symbols that form on either end, what we're really talking about here is cardinality. How many participating instances of these entities are involved in the relationship. Let's look at the lines closest to the entity patron. The outside symbol, the one farthest away from patron, represents minimum cardinality. Because it's a vertical line, it means 1. The inside symbol, the symbol closest to patron, represents maximum cardinality. In this case, it's also a vertical line, so it's also a 1. Now on the other end, the one closest to pet, we see two different symbols. A circle on the outside symbol, representing minimum cardinality, represents 0, meaning that this relationship is actually optional. The symbol closest to pet are crow's feet. This represents the maximum cardinality, and the crow's feet indicate the word many. Now what's tricky about this is how you read the relationship. As you read from one entity to the next, for example here, patron, we would say one patron is associated with, or is related to, however you want to phrase it, 0 or many pets. So if we begin with patron and we read over to pet, what we focus on are the symbols closest to pet. One patron is related to 0 or many pets, meaning that a patron may have no pets or may have many pets, where many is 1 or more. If we look at the relationship in the opposite direction, we say that one pet is related to one and only one patron. So when we read it from pet to patron, we use the symbols closest to patron. The two vertical lines mean one and only one. Take a moment to examine this diagram and make sure you understand these concepts before moving on. When it comes to cardinality, we have it broken down here on the diagram into minimum and maximum. For minimum cardinality, you saw a vertical line representing 1, and you saw a circle representing 0. When we have a circle representing 0, what that means is that relationship is optional. If we see a vertical line, it's a mandatory relationship, meaning we have an existence-dependent relationship. And we'll talk more about that in the future. In terms of the maximum cardinality based, really it depends on what's going on. What are the issues involved, or what are the concerns involved with this particular type of relationship. But in general, there are 3 types. One to many, or 1 to m. Many to many, sometimes mentioned as m to n, or 1 to 1. Here's an example of an ERD in a different diagramming tool. The one you saw previously was generated in Lucidchart, something you'll use this week. Visio is a Microsoft product that also produces ER diagrams. We don't have access, at least not everyone has access to it here at Penn State, so we don't use it anymore. But if you see, look here, many of the symbols are the same. We see crow's feet, we see lines representing 1, we see circles representing 0, and we see dashed lines representing relationships. The solid lines mean something slightly different, and we'll talk about what that is here shortly. You'll also see that there's more clear designation of primary keys and foreign keys, not just underlining, but the symbols PK and FK. So you will see some variation between the different tools. Some are more complete than others. For this class, we're going to focus on Lucidchart because it is a simple tool to use, and will do everything we need it to do. And it's free. So we're going to delve a little bit deeper into relationships right now and focus on 3 types of relationships. Something called identification dependency, self-referencing relationships, and how many-to-many and one-to-many relationships can be made equivalent. First, let's start with identification dependency. This involves that concept of weak entity that we mentioned previously. In this relationship between service and appointment services, you see a relationship line which is not dotted, but is rather solid. The solid relationship line indicates that this relationship is identification dependency. What that means is on the many side, there is a weak entity. This entity is entirely dependent on the entity's service, which is a strong entity. When you have an identification dependency, you have a solid relationship line, And on the many side of this particular relationship, you see service ID, which is part of the primary key. It's underlined, but is also italicized, meaning it's a foreign key. Appointment services has this composite primary key of appointment ID and service ID. Because appointment services is weak, what that means is it has the primary key of the strong entity as part or all of its own primary key. And that also means that, in this case, service ID is a foreign key back to service. That's the linkage between these two entities. Because service ID is part of the primary key of appointment services is considered to be a weak entity, and the relationship between these two entities is considered to be an identification dependency. Sometimes we have self-referencing relationships. In other words, relationships between an entity and itself. For example, let's suppose you have some sort of entity representing your staff. You might have a staff ID field and a name field, but it may also have a supervisor ID field. Now, if you lump supervisors in with staff, you may cobble together all of your employees under one umbrella, in this case one entity called staff. You can have relationships between an entity and itself. In this case, we have a relationship for supervisor ID. Now, it's listed here as a foreign key. In supervisor ID, you would actually have a staff ID representing the staff ID of the supervisor of that particular staff member. Now, the relationship here is one-to-many. One staff member supervises one or many staff members. And each staff member has 0 or 1 supervisors. Depending on the direction you read, you're going to read it slightly differently. One other thing you're going to notice here is that the relationship has a name on it, supervises. Many times with relationships we name them to indicate a little bit more detail about that relationship. That's entirely optional, but you will see that very often being done. When we talk about relationship equivalence, we're talking about many-to-many relationships. They're particularly thorny to do in a commercial database. So what we often do at the design stage is something we will ultimately need to do at the implementation stage. We replace a many-to-many relationship with an associative entity type and 2 identifying one-to-many relationships. This is largely a matter of preference, but well, as I mentioned, you ultimately will have to do this in implementation, so it's just easier to do it during the design stage, and something we should always do. For example, here's an associative entity type. Expanding a little bit on expanding a little bit on one of the concepts we saw earlier, here we have 2 entities, service and appointment, both of which are strong entities. But we see here in the middle an entity called appointment services. Appointment services is the associative entity, meaning it implements the relationship between service and appointment. It ties the two together. Now, from this, you'll see we have 2 identifying one-to-many relationships. You can always spot a one-to-many relationship because on one side you will see no crow's feet, and on the other side you will see crow's feet. Now it's identifying because they're solid lines, but the associative entity type that you see here has a composite primary key. The composite primary key is made up of the primary keys of the 2 entities in which it's associating. In this case, appointment ID from appointment and service ID from service. Now, the reason we do this is that service and appointment have a many-to-many relationship. If we were to read that relationship in both directions, we would say that one appointment can have many services, and one service can be part of many appointments. When we have a many-to-many relationship, we need to break it down into 2 one-to-manys with an associative entity, and that's what we have here. You may also notice that there are some foreign keys here which are not linked to anything. Pet ID and staff ID, for example. The reason for that is we just removed them from this diagram so that we could focus on the associative entity type information.